Hello everybody, and welcome to another video. This is right triangles and stuff, which is chapter 9 of our actual geometry curriculum. I know some people are saying that they were struggling on this a little bit, and I get it. It's a lot of different new topics and different things you can do with right triangles, so I thought I would go through it, get a good idea, hopefully strengthen your understanding of this concept. Let's get right into it. Right and wrong, obviously there's no such thing as a wrong triangle, but in terms of right triangles, all you gotta do is look for this little box in the corner there. Hopefully you all know this, but just getting us all on the same page, which means 90 degrees. And it doesn't matter where it is, it can be up in this corner too. And for this one, you couldn't really assume that this was a right triangle. You don't really know because there's no box, there's no 90 degrees, there's no nothing. Like, I know it's a right triangle because I put it in the presentation, but you can't assume that in geometry. So just a little reminder that unless there's a box or a 90 or maybe like something else, like if this was a whole like an altitude, if this was an altitude, you could say that that's 90 degrees as well, but otherwise you don't know. So just a little reminder on that. And there's also some vocabulary to go through. Hypotenuse, legs, adjacent and opposite. This one is the Pythagorean Theorem version. So like a squared plus b squared equals c squared. Hypotenuse is your c. Legs are a and b. And this is only in regard of from the perspective of, that's what I'm looking for, from the perspective of the right angle. So you have the hypotenuse, which is opposite to the right angle, and then the two legs on the other side. This is the trig version. And this one, you have the hypotenuse, which is still on the other side of the right angle, but then you have this theta here, which is like your other angle that you're looking for, and then you take the opposite and the adjacent to that angle. So this is really just like, this is adjacent and opposite legs still, so they're the same thing, it's just you have another angle to think about from this perspective. Hopefully that clarified and didn't confuse you, but we'll get more into this later. I'm going to start with the altitude-on-hypotenuse theorem. Just as a review, that the altitude is anything where you take a line to the top of a triangle so that it makes two right angles at the bottom. And so when you look at this picture here, this is a hypotenuse, and here's your altitude on hypotenuse. And I gotta say, there's not a lot of things in math that I don't like I actively dislike, but this is one of them. I don't like this one that much. And it makes it a lot worse when you have like AD over BC equals, and all this. I don't know what it actually is, but there's a lot of letters to go through, and it's just a pain. So I'm going to start by saying, you got your big right triangle here, and then it's cut by this altitude, so it makes two little right triangles. And the cool thing about this is they're actually all similar to each other. So this whole big one is similar to this medium one, is similar to this little one, and that's what this is showing here, but it's not really to scale, which is a little annoying. So basically, all that to say, we can prove things using that. Like, I won't go through the proofs because that would take a long time, but we can prove these two theorems, which are the altitude on hypotenuse theorems, and do a little bit of math there. So I'll get into this for realsies now. There's a lot of things going on here. I would say we can start with Theorem 64. If you have, it's really a game of what do you have and what are you looking for. So when I say, if you have something is like a number, a variable, or anything that you're looking for, So if you have something in your h and then an x and y, then you're gonna fulfill this one. H, it's a little confusing. I kind of wish h was the hypotenuse, but h is the altitude, and this one kind of sticks out. So if you have anything here, then it means you're going to be using this theorem, and all you have to remember is altitude and then two parts of the hypotenuse of hyp. So that's the trick for that one, and that one is pretty simple, pretty straightforward. And then here, I'm going to clear this. And the other one is when you're looking for these other legs of the big triangle, because remember, this is the hypotenuse, you got the two legs. When you're looking for the legs, you have to use the whole hypotenuse, and then the other like side of that triangle that you're looking for, or like the nearest part of the hypotenuse, which is a little more complicated than just this part. So, for example, if I was looking for A, if A was my x, so to speak, well, that doesn't really work. I can't really say A is my x. A is my A. I'm looking for A. Uh, then you would use this theorem here, and you take the whole C, let's say it's like 20, and then the two A's, which are here, and then this x, which could be like 5. So I'll say this is 20. And then you would cross multiply this, so you could say a squared equals 20 times 5, which is, hold on, 120. So I don't know if that actually makes sense as like a equation. It's probably going to come out to something weird, but I think, to me, the most useful thing to remember about this is, what are you doubling? Like, what has what shows up twice in the equation? And for these ones, it's always going to be the legs of the big triangle, that is. So the A and the B. And for this one, it's always going to be the altitude. Hopefully that made a little bit of sense. I'm kind of just saying random things because these are the things that helped me. And I don't know, it's not super intuitive. Memorize it is really what I would say. And make sure you know where all the different parts are. And if you look down here, this is Cliff Notes. This is where I got the diagrams. It's also a good resource. Or just Google it. ChatGPT isn't such a bad thing. You can ask it to help you out with these kind of things. But I'll move on now. Next we have the Pythagorean Theorem, which I kind of touched on earlier. Hopefully you should know how to do this, but basically the big reminder is that your hypotenuse is always C, and then the legs are A and B. And actually, I won't go through this all now. Let's go to the Pythagorean families. These are ones that you can always plug into the a squared plus b squared equals c squared, and they work out. And they'll be like whole numbers, because oftentimes when you square root things, they won't be whole numbers. So this, like the 3, 4, 5, 5, 12, 13, all these different things. The most important thing to remember is that this last number in all these triples is the hypotenuse. And so what I'm going to bring up here about using the Pythagorean theorem, which is what I was going to remind you earlier, is you have to make sure you have the hypotenuse in the right place, because otherwise it's never going to work. So if I have like a triangle like this, where it's like 3, 4, x, and this is the right triangle, you could not call that 5, because it needs to be the hypotenuse that's the longest one. So let's take this as an example here. We know 4 is our c, so 4 squared, and then x squared plus 3 squared. 3 squared is 9, and 16, x plus 9 equals 16. Subtract 9, what is that, 7? I think that's 7. So x equals square root of 7. Yeah, there we go. So, it's a lot different. If you thought this was a 3, 4, 5 triangle, and you just put a 5 there without thinking about it, you're going to be a way different answer than square root of 7. Hopefully I got that right. I'm kind of going kind of fast. I'll let you know if I didn't. Let's just move on from this now. Look at that. They named this type of triangle after you. These are special right triangles. Basically all this means is, some mathematician at some point in time figured out that if we have these certain angles, which is 45, 45, 90, I'll write these out, because why not? 45, 45, 90, or these ones here, 30, 60, 90, then they'll have these certain length properties. Now, I think this one is pretty much the easier one, because these two are going to be the same, and this one you just stick a square root 2 on the end. The only thing with this one is, if you have something where the two legs here are congruent, then that will make it a 45, 45, 90. So it doesn't need to necessarily say the 45, 45 part, as long as you know that they're congruent. That's just due to the nature of how those work. As for 30, 60, 90, mostly where these come up is as an equilateral triangle, because when you know it's equilateral, then you know each corner will be 60. And if you draw an altitude, then you know that these angles will be 30 because it's split. So here, I'll clear these all off. I can only clear things all off all at a time. I don't like that I have to do that. Anyway, you're just going to have to remember these ones, that whatever's across from the 30 will be A, whatever's across from the right angle will be 2A, whatever's across from the 60 will be A root 3. And also just a reminder that, like, what would be an example? Like 21 divided by root 3. If we had 21 divided by root 3, because, like, I'm thinking in a case where you'd have to divide the root 3 off of this A to get the normal A. You can't leave a radical in your denominator, so you're supposed to multiply it off to get it off of here. Because this is the same as just saying 1, and you're allowed to do that. That doesn't change anything. So any square root times itself is just a number. So you have 3 on the bottom, then 21 root 3 on top. Then you can just simplify these out to get 7 root 3. So the trick that you're supposed to use for these is if you have something like this, you just divide it by whatever's in the square root and then stick the square root on the end. So you can just divide 21 by 3 and then add the root 3 in the end to get 7 root 3. That's all about that. And it's all fun and games until you need new buttons on your calculator. Yes, it's very exciting. Mr. Colander's all-time favorite of the TI-30 multi-view. I don't know why that guy talks about it so much. He loves the TI-30 multi-view. But yeah, check it out. I don't know, it's a little small here, but sin, cos, tan, sine, cosine, tangent, and the lovely song to go with it. This isn't that bad in my opinion, but you really do have to remember your so, ka, toa. And, of course, for those of you that don't know, hope you do know, though, because this is kind of our whole unit, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. All these really are like mathematical ratios. This is, again, some mathematician at some point in time was like, hey, you know, I've noticed that these are always the same for whatever certain angle. And they do come up a lot in higher level math, so it's important that you know these. I forgot about this slide. Sokotoa, 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 sokotoa. Oh, this actually takes thinking. Yeah, it does take thinking. So let's go through this for a second here. Theta is always the angle that we're looking for. I don't know if you guys know that. Like, usually we're looking for x, but when you're looking for an angle, you usually call it theta. When you're trying to find the sine of something, it's the opposite over hypotenuse. Well, half the battle is finding out what is the opposite and what is the hypotenuse. If this is your theta, this is the opposite, and this is the hypotenuse. I mean, it's really that simple. So anytime you have, like, if you have an x here, and a number here, and a number here, the two things that you have are your opposite and your hypotenuse. So all you could possibly do is the sine for this one. You know, like, and then you do it for all these other ones too. Like, if you see that all you have is, for cosine, all you have is the adjacent and the hypotenuse, then you have to use cosine. So it's really just, it's kind of like a vocabulary test, but with more steps, you know, finding out which side means what. And then there's the whole thing of, if you have something like this equals, you know, something over something, in order to get this x out of here and to solve for x, you have to do the inverse function, which is the -1. You know, you have that button on your calculator, and then you do whatever this is. And then there's also the whole thing of, if you have, oh wait, I did that wrong. If you have sine of a number and it equals x over this, then you just multiply by that. That's just basic multiplication rules. If you have sine of a number and it looks like this, then you just switch the x and the trig function. So I'm being very non-specific here. I'm not using any actual real numbers, but I think the thing from the video goes, x is up high, cross multiply, x is down low, switching them which doesn't rhyme. That really bugged me. Like, to switching you go would have made sense. Whatever. Not my video, not my problem. So, the grand question to end this video is, when do we use what? If you know, like, if you got the study guide already, I'm going to pull it up here. If you have the study guide already, you look at it and it's just a bunch of triangles, and you have to figure out when you're going to use each one of these things. So, like, it's going to probably take half of the time that you use to actually solve the problem to just figure out which method you're using. And here's my cheat sheet here. If you want to take a screenshot of anything, I would take a screenshot of this. So if all the three sides have something, if you have a number here, and like an x, then that's Pythagorean Theorem and then families. If you have like something here and something here, but then the angles are labeled, and it's 30 and 60, or some such thing, you know. I also said the thing where if you have an equilateral triangle, this is also 30, 60. Or if you have like a square, this would be 45. Anyway, I'm kind of just rambling. All of that to say, anytime you see those angles or something that would allude to those angles, you can use the special right triangle theorems. And then if there's two sides and an angle, pretty simple, then you do right triangle trig. So that is all for this video. I took it pretty fast because I want to go to sleep. It's pretty late. But feel free to let me know if you have any questions, or if you want me to work through anything. Should be all there is. Good luck on your tests, everybody, and I will see you next time. Goodbye.